Hello, my name is Dmitry Soshnikov. I'm Cloud Developer Advocate at Microsoft, and today I will share with you my ideas on how to win a hackathon. I have a lot of experience with hackathons, sometimes as a participant, but mostly as organizer, so I will share my experience from the other side, from the judging side, but also as a participant. Hackathon is a great way to come up with the new ideas and to create a startup. If you create a startup in real life, you typically start with some idea, and then you try to figure out the business model, like whether this idea would be so useful to people that they are ready to pay for it. And once you figure out that business model, you start with MVP, you create a prototype, and then you start creating business around it. But at hackathons, it's normally in hackathons you start, of course, with an idea, and then you work on the MVP without thinking too much about the business side. And then after the hackathon, you can in fact think whether what you have created is useful. I am a technical person. I personally love thinking about technology, and that's why when you think about ideas at hackathons, ideas are very often driven by technology. So great technology can drive you to great ideas, and then you figure out if they would be useful or not. And, like, why are we coming to hackathons? Of course, that's a great experience. We enjoy taking part in hackathons. Of course, offline hackathons when people actually get together and spend the night and a couple of days in one location is a great experience. It's very energizing. But online hackathon can be very rewarding as well, especially if you remember that speaking with people, getting new contacts, and communication is an essential part of it. Online, it's a little bit more difficult to communicate, but if you keep this in mind, you can achieve the same effect of being present at the event as as with the offline event. Uh, as I mentioned, creating a startup often starts with a hackathon, but of course also everybody wants to win. And winning a hackathon is a very pleasant experience, believe me. So what is the best way to win and what is the most important thing to keep in mind? Really, that is focus, because at hackathon you have very limited time to create your project, so you need to be doing only important things. For example, do not think too much about the great architecture for your product. You would have the time to do that later on when you do the next revision or come to the next sprint. The first sprint at the hackathon is very important to create some sort of working prototype, but you don't have to think about all the details. Focus on what you will show at the end of the hackathon, because you need to create some demonstration. So effective demonstration is much better and is much more important than good architecture of the product. And also effective pitch, how you speak about your product, is as important as the effective demonstration. So when you have a team, try to see who would be the best one to present, who speaks in the most engaging way, and he can focus on presentation, on putting together like slides and arguments and those things. And there are normally people who prefer to work with technology, who should be developing the product right away. And during the pitch, you don't have to think to say obvious things, because normally at the hackathon, the pitch is very limited. It's like 3 minutes or something like that. In 3 minutes, you don't have to say how important it is, like communication for our life. Everybody understands that. But try to make the point, like why your project is unique, why is it better than competitors, and so on. So another secrets how to make a good impression on the judges is like if you show an application prototype which is beautifully designed. So do not think that a command line interface, for example, is enough. If you create some kind of visually impressive interface, that's a good indication that you are taking your project seriously and you will be putting it further. Another few things are like if you present your emails, if you have your own domain, that's also great. So if you participate in hackathons regularly, try to think about some kind of branding for your team or something like that. So those little details can play some important role, but it's important not to spend too much time on the internals of your project. I mean, on the non-essential parts, which you will not show to the judges during the presentation. Focus on only things that you will show. And that's why it's very important to select right technologies, because there are some technologies which are very good for creating big and large scale projects, but they are not as easy when starting a small demo prototype. That's why it's important to choose the technology. Of course, the best technology you should always choose is Visual Studio Code, because Visual Studio Code is a great editor which allow you to be very effective on any platform. But let's focus more like what can you use besides of Visual Studio Code. Normally, teams that participate at hackathons professionally, they have some kind of building blocks which they know how to use. For example, when you want to create a website, you start with a bootstrap and you use like Heroku for web hosting. When you create mobile app, you can have some kind of Xamarin project ready, which is easy to build on. And then like for mobile backend, you can use Flask. For IoT client, Raspberry Pi with Raspberry, and so on. Normally, you can think about those things in advance. Even if you don't know the topic of the hackathon, you can think about which technologies you are proficient with and which of them you would use for different tasks. When you are using cloud. Cloud makes it much easier to build applications because it already contains some building blocks. On the basic level, any cloud consists of some infrastructure, which is virtual machines and storage. But building everything on top of virtual machines is not very practical, because once you create a virtual machine, and for example, if you want to host a web application, you would need to install a web server. If you want to host the IoT system, which would receive the data from some sensors, you would need to host the MQTT queue or something like that. But in the cloud, there are some services available ready pre-built for specific tasks. For example, if you want to build a web application, you use Azure Web App Service. With it, you can just say, I want a web application in the cloud, and everything is created automatically. You don't have to think about which virtual machine this website would be executing on. And there are platform services for many other tasks. For example, if you want to create the mobile backend, there is the Azure mobile app, which contains both storage and different authentication capabilities, which are very typical for mobile applications. So you can easily connect this cloud backend to your mobile application in Xamarin or iOS or Android. Then if you want to deal with IoT, there is a whole bunch of services for Internet of Things, for ingestion of messages, for processing of messages, and for accumulating them and analyzing them afterwards. The same is true for artificial intelligence, starting from some pre-built models which solve very typical tasks like identifying person on the picture, to specific Azure ML service which would allow you to build your own machine learning models from scratch. So if you're using cloud, it's much better to get familiar with those kind of platform services and focus on them. So when you think about your project for a hackathon, you need to think about some kind of user interface, the client side of the application, and some cloud side of the application or the server side, where the logic would be. Because most of the typical modern applications, they are split between some server side and the client side. So the easiest the easiest UI for an application would be a console application, because it's request response model. You type something, your application computes the result and gives it back to the user. But that's not very impressive, because interactive with console application is considered to be like a hacker style of using a computer. So that's why judges probably would not think this is the user-friendly application. So most applications, most interfaces which I see at hackathons typically are web applications. Web application is definitely a very good idea, because judges can type in the URL and they can test your application as well from their phones or from their computers. But there are some, of course, there are some advices on how to do that. For example, knowing that judges might access the application from their phone, you should probably take the design which is responsive, so that it looks good on the phone. And taking some ready-made UI libraries like Bootstrap is a very good idea to do that. I will not go into details about web application. I have provided some documentation here because like web app is a very typical thing, and there are a lot of documentation on that, and you can create a web app in almost any language or framework you can think of. Of course, you can do it in Python, you can do it in C#, you can do it in Node.js, and so on. The next option would be mobile application. Mobile application is probably not the greatest idea because there is much more overhead related to mobile applications. Like you need to think more about design, you need to think more about like how pages would interact with each other. But if you want to create a mobile app, you can try going with Xamarin platform because you would end up with a cross-platform application, and also Xamarin is not a very complex platform to start learning. So Xamarin, I have provided some documentation here in case you decide to do mobile app, but please don't. Then another option, like if you're doing IoT stuff, when you have sensors which collect data for IoT client side, you probably would want to use some kind of sensor or device like Raspberry Pi or Arduino. If you are using Raspberry Pi, normal solution would be to use Linux, but I just wanted to mention that on the Raspberry Pi you can also run Windows 10 IoT Core. And the advantage of doing that is that Windows 10 IoT Core has some quite advanced built-in capabilities. For example, you can easily connect the USB webcam to it, and USB webcam would be accessible from .NET using the same APIs as for Windows Phone or for Windows Desktop. So you would have some features like face detection already built in. So like if, for example, if you are creating an application which would monitor people, you can easily detect if people are present just on the client side without doing the round trip to the cloud. And finally, yet another option is creating a chatbot. And chatbot is probably the best idea for a hackathon because in terms of application model, it's the same request response as with the console app, because the user types something to the bot and then he receives the result from your application back. So very easy to develop, but also it's quite impressive because bots are a popular way of making apps available publicly. And you can also like give the bot handle to all the judges, and they would just add this bot on Facebook or in Telegram and would test it in the same way as with web application. But you don't have to think as much about design, because with bots you focus on content and not on design. That's why I believe bots are the best way, and I have provided some documentation to Microsoft Bot Framework, but I will also talk a little bit more about it. So Microsoft Bot Framework is a way of creating bots which allows you to develop a bot as a web service. So bot in the Microsoft Bot Framework consists of two main parts. First of all is the web application, which is a web service, providing the function to generate a response. So when you are creating this web service, all you need to do is you need to write a function like that, which would accept the message as a parameter and generate a response. So a very easy programming model. Then once you have this web application, you also have bot connector, and bot connector is the typical Azure object which connects this web service to the messaging platforms. So you can manually specify in the bot connector that you want to connect this bot to Telegram, for example, you want to connect it to Facebook, and one bot logic which you have created in the web application would be available to the user in different messaging channels. So that's why it is quite useful, and creating this connection is just a matter of few clicks in the web interface. Let me show you how easy it is to create a bot with Microsoft Azure. I will start with the Azure portal, portal.azure.com, and I will create a chat bot there. So once we have the portal displayed, I say create resource, and I select a bot. And we will use a web app bot, which means that I will create a web application that will host the bot service and the connection to the different bot channels at the same time. Let me click create, and then let it be a demo bot, the name. I will create the new resource group, which will hold all the resources for this bot. Okay, location would be West Europe because that's closest to me, and I will choose the free pricing tier, which would be more than enough for a hackathon. And I will start with the bot template, which is called EchoBot. EchoBot is the simplest bot which will just echo back all the messages you type it. And basically that's it. I just need to make sure that application and site is located in the same data center, and I click create. Once the bot has been created, let's go to resource groups and find it. It was called DemoBot. And in our resource group, I see three objects. One is the application insights, which tracks the usage, which is not very important. And then web application and the bot connection. The bot connection is the main object. I can test the bot from here. So for example, I can say I want to test it in the web chat, and see that my bot is already responding to my messages. So if I type something as like hello, it will say me echo hello. The bot is working, and I just need to change the code. So when I go to the initial overview page, it gives me all the steps that I can do with my bot. So first thing I need to do is I need to build the bot. I can go to this build blade and download its source code to start playing with the bot locally. I download the code, and then let me extract it to some directory. And I will open this directory in Visual Studio Code. So how does the bot look like inside Visual Studio Code? It is a normal ASP.NET application. You can see that program CS contains the normal startup code. And the main logic of the bot is located inside bots directory in the file called echobot.cs. In this file, the main thing is this function here, on message activity async, which is being called to process each incoming message. And the argument here is turn context, which contains everything about the message, from whom the message is, and most importantly, the message text. So turn context.activity.text contains the text which was typed by user, and you see that um, I assign the reply text and send it back using send activity async. Everything is asynchronous, but C# allows to develop those asynchronous functions pretty easily. So the first thing we would probably want to do is to be able to debug this bot locally. I can run it from here. When I do it the first time, I need to select the runtime environment, and yeah, then I can just press it again, and the bot is running. It will open in a few seconds in the browser page locally. And to test the bot as the bot itself, we need a special thing called bot emulator. You can download it from here. There is a link here to the emulator installation page. And if we already have it installed, then I just start it. And here we see the endpoint of the bot, localhost 3978 /API/messages. What I also need here is Microsoft App ID and Microsoft App Password, which are used to protect the communication with the bot. And those App ID and App Password I can get from Visual Studio from appsettings.json page. So I copy App ID here. I need to do it luckily just the first time I do the development. I put it app ID here, and then I put app password here, and I say connect. And we are connected with the bot. We can start chatting with it. I can say hello, and the bot says echo hello, because that's how it was programmed. Now, if I want to change something, I can go here. I can stop the bot. go to echobot.cs and um, just let me do a very stupid modification here, just to see how it works. And once I start chatting with the bot again, we just need to wait for the bot to power up, probably. Yeah, you see, the bot is now following the new logic. That's the bot running locally. If I want to deploy it back, what I need to do, I need to deploy it back to web application. And in the Visual Studio Code, I need to have the Azure extension installed. And once I have it installed, here inside the app service part, I would see all my web applications, including the demobot 13, which is related to this bot. And if I want to deploy it, I just say I want to deploy to web application. I select the directory of the project, and then I just say deploy, and the application is deploying. Once the deployment is completed, I can go back to my Azure page and test the bot in the web chat. Inside this web chat, it will now use my new bot logic. But bot inside the web chat is not very useful. The most interesting thing is to be able to connect the bot to different channels. So here I can, for example, connect the bot to Teams, to different communication channels like Skype, Facebook, and so on. Let me show you how to connect the bot to Telegram. That's the easiest thing to do. Basically, what I need to do, I need to create the bot inside the Telegram and paste the access token here. If needed, here we have the link to the step-by-step instructions. You can click and see all the detailed descriptions, but I will show you how it works. So here I say I start chatting with botfather. Botfather is the bot used to create bots in Telegram. And I say new bot, demo 13 bot. The names of the bot should end with the bot, and I get the access token. I just copy the access token from here, paste it into the Azure control panel, and the bot is good to go just in a few seconds. Now, demo 13 bot. I look for this bot, I add it here, and I can start chatting with my bot right from the Telegram. So you see, it takes just a few minutes to get your bot up and running in Telegram. Now that we know how to create user interface to our project, let's focus on the server side in the cloud. And of course, the most interesting modern applications, they involve artificial intelligence in some form. For artificial intelligence, there is a rule called 80-20, which means that 80% of the tasks, they are very typical. And luckily, Microsoft Cloud allows you to solve those typical tasks very easily using cognitive services. Cognitive services are pre-built models for solving traditional simple tasks of vision analysis, language analysis, and so on. However, if you want to do something yourself, training your own models, there are also many tools. First of all, you can create your own data science virtual machine, which means that you can have the environment for training your models in the cloud up and running in a few minutes. And data science virtual machine would include Python distributions, all the libraries, TensorFlow, pre-installed and ready to work on GPU. So you don't have to spend time trying to set everything up. Another very useful tool which is available even free of charge is Azure Notebooks. Azure Notebooks are Jupyter notebooks available in the cloud, so that you can go to Azure notebooks.azure.com and start working with them immediately without setting anything up, just having your Microsoft account. And then if you want to train something really serious and big, you may want to learn Azure Machine Learning Service and Azure Batch. Those are services which allow you to train your models at scale and with a reasonably low cost. But I will not talk more about them. Just if you're interested in, have a look in the documentation. During Hackathon, you want to create something impressive very fast, and cognitive services is the best way to do it. In cognitive services, there are pre-trained models which solve very typical tasks. For example, tasks related to computer vision, when you give computer an image and it can extract a lot of information from it, including detecting different objects, like common sense objects, and also objects that you want to train the model to recognize. Then there is a group of services which deal with human face. You can, for example, identify if two faces belong to the same person or not, or extract age and emotion information from photograph. And there are services which do optical character recognition, including handwritten text. So, for example, if you have a collection of photographs of documents, you can extract all the textual information as well. Another group of services is related to text. A good example of their usage would be if you want to index social networks and see if certain brand has positive or negative perception, you can use sentiment analysis. You can use keyword extraction to roughly determine what people are talking about. And if you have some application which receive commands like text commands or speech commands, you can try to extract the intent, what the command actually means, using the service called Lewis, which you can train on examples. Finally, there is a group of services which handle speech, which allow you to convert text to speech, speech to text, and do some machine translation, either in textual form or in the form of voice. And then another useful service which is worth mentioning is called Azure Search. Whenever you have a collection of documents, including some images, you can ask Azure Search to index it, extract whatever information is possible from this collection, and then you have the interface which can query those documents and find relevant ones. Let's now develop our bot into the actual application, and the application will be the following. It will take a photograph of a triumphal arch. Triumphal arch is the arc similar to the one on the picture, which are available in different cities. And the user would send this photograph to the bot, and the bot would tell the user which city is it, like whether it's Moscow, Paris, or something else. So what happens when a user sends picture to the bot? Inside bot framework, it is being delivered as an activity. Activity would have some text associated with it, like for example this one, hello, and then it would have a list of attachments, and each attachment is represented by the URL. So this image is temporarily stored somewhere inside Telegram, and the URL of this attachment is passed to bot framework. So we can use this URL to see the picture and to use one of the cognitive services to classify it into one of the cities. Let's see some cognitive services in action. To do so, we go to ak.ms/cogn. That's the easy to remember address, and here you can see the all cognitive services that are available. As I mentioned, language, speech, vision, and so on. Let's see vision because they are most spectacular, and start with computer vision. Computer vision is the service to which you can give the image, and it will find all possible information from it. Here, right from the web page, you can see the demonstration. You can click on one of the images which is already available here. For example, this group of people, you can see which objects the computer vision service sees. It sees the laptop, it sees the seating, the sofa, and those kind of things, people, table, and so on. And all information in JSON which is returned from the service you can find on the right. Objects with coordinates, tags, and even the description of this image as the English natural text. That's very impressive, isn't it? Then, for example, another useful service is dealing with face. So Face API is available inside the same vision group, and it can detect different things like age, sentiment, and so on. So let's just try one of the images here. And The detection model here, detection 0.2 is the new one, so it doesn't give a lot of information. Let's try detection 1. It gives us face attributes like hair color and things like that. It gives us head rotation angles, smile, gender, age, 33 years old, and many other things, including, as I mentioned, emotional analysis of the face. And you can even try it with your own photograph. Like here, if you select any photograph like this, for example, you can see the result of applying this service. But the most useful one is so-called custom vision. So let me go back to cognitive services, vision, custom vision. Custom vision would allow you to recognize your own object. So in my example, I will create a service which recognizes different triumphal arches. So to start with, let's go to customvision.ai. And customvision.ai, after you log in, it contains different projects. You can start a new project here, but I will open the existing one called arcs. And arcs is the model trained to recognize different triumphal arcs like that in different cities. And those arcs are available in several cities. Here I consider Moscow, Paris, and Bucharest. You can see that I uploaded pictures for every city, like a few of them. 15 pictures for Bucharest, 14 for Moscow, so not a lot. Just a handful of pictures from different cities. And I want to train the model to recognize them. So after I uploaded images, I click on train. It trains the model and it gives me the accuracy. Surprisingly, I have very high accuracy here, and probably that's because the arcs are quite different. You can actually test this model. I can go to bing.com and search for any triumphal arc over here. Just let me take first available one. It doesn't look like, yeah, this is probably one from, I don't know where is it from actually. But let's take the URL from here and find out. We paste the URL and it tells me this is Moscow with 99% probability, which is quite good. I can also upload my own picture, of course. Now if I want to make this model a part of my application, I go to prediction URL and it gives me the URL which I can use to call the model from any REST service. To incorporate it into my application, into my bot, what I need to do, I need to install the NuGet library first. So if I have the NuGet extension installed in Visual Studio Code, I just say add package here, and I type custom vision because probably that package would contain the name custom vision, and immediately I see two NuGet modules, custom vision prediction and custom vision training, and I definitely need custom vision prediction. Let me select the latest version, and I want to build it inside the EchoBot project. And that's it. I have installed the library. Now let's delete everything in onMessages activity async function and start programming it from scratch. So the first thing I will do is to get the URL of the image which the user sends to the bot. To do that, we use the activity attachments. So activity has some attachment array, and if the length is more than 0, then we can take the first element and take the content URL from there. Of course, to program it properly, I need the if check. I need to check if there is more than 0 attachments I can take and process them. If there are 0 attachments, I should probably say that something is please assign the image and send it to the bot. But for the sake of time, I will not do that. I will just take the URL, assuming that a user always provides an attached message. Then I convert it to a different type of image URL, which is the type which is taken by the custom vision model. So then what I need to do, um, I need to instantiate the custom vision prediction model from the NuGet library which I have installed. If I start typing here, for example, new Microsoft dot cognitive services dot actually Microsoft.azure.cognitive services.vision, I can actually get to this name. So I will, that's how I figured out the complete name. So you instantiate this cognitive custom vision prediction client. For the client to work, I need to provide the keys. So I set the API key and endpoint. Where I take them from? I take them from the web page here. Here is the prediction key, the API key, and the endpoint is the server address here, South Central US, apigcognitivemicrosoft.com. That's it. Then, what I need to do then is to set up project ID and iteration name. Again, from this web page, project ID is available as part of the URL here. This GUID here is the project ID. And iteration name is iteration 2 here. We can also get this information, of course, from the page here. Here is the iteration, the name of the iteration, and project ID is available from setup page, for example. This is project ID. So there are different places you can find it from. So project ID should be converted to GUID, and the iteration name is just string. Now, to get the prediction, I make the call. So I say result is classify image URL with HTTP messages async, and I pass project ID, iteration name, and image URL. So that's pretty simple. And I have this res, which is the result of the request. From the result, I can say that result body predictions is the array of different predictions. The model does several predictions with different probability, but the one with highest probability always comes first. So that's why I can just take prediction 0 here and print the tag name. Tag name is the name of the city in my case. And let me change the message. Here the city is and the name of the city. That's it. Now I can publish this code online to Azure. I can say deploy web app. And because I have already deployed the web app, I don't have to specify any parameters. I just say deploy. And it is deploying. It will take a few minutes to deploy. After which I can go to my Telegram bot. Now, yeah, it's completed. I can go to my Telegram bot and send it the image. I have the image of Triumphal Arch here. I just send it to the bot, and I will, in a moment, get the result from it. That's it. The city is Bucharest, and you can also see this from the flag. So you see, it's pretty simple to get the working bot straight away, which is calling our custom vision service, and actually does something useful. The next extremely useful server-side technology is called Azure Functions. They are also called serverless applications because the idea of Azure Function is to give you an ability to write some code which would be executed in the cloud without you thinking about where and how this code will be executed. So, for example, if you want to create a function for our bot that will take the image posted by the user and save it to some storage, the best way to do it would be to use Azure Function. So first of all, Azure Function is serverless because you just provide the code. And secondly, Azure Function can be bound to certain events and to certain Azure objects. So for example, if you want to store the incoming image to the Azure storage, you would bind this function to incoming HTTP request, and then you would bind the output of the function to the storage itself. So the function itself would just be the code which takes the image and puts it into the output parameter. And the actual process of accessing the storage would be done automatically by Azure Functions runtime. First of all, I would need to create the storage resource for images. So I go to creating a new resource and select storage. And for the storage, I choose existing resource group with the bot. Let it be demo store 13 the name. And standard storage, the cheapest version is locally redundant storage, which means it's not duplicated across data centers. And then I say just review and create, because all other parameters are by default. Then let's create Azure function. We select function app as the resource type. Then as a resource group, I would select the same demo bot as all the objects in our bot, and then the name would be storage func. I can design the function either as Docker container or by providing the code. The code is probably the simplest one. The runtime stack would be .NET, and the region should be also European, because everything is in West Europe in our example. Then you can see that we can host it on Windows or Linux platform, and it doesn't really matter which one. And the plant time is an important thing, because we can design function to be premium, which means it will have a dedicated virtual machine, and we can select the size of the machine and how much computing power would be available. Or we can select consumption serverless, which means that the Azure infrastructure will take care about the execution. We don't have to think about all the details and about scalability. So serverless is probably ideal, and I will select the existing storage account. Then let me not select application insights, because in our example monitoring is not something important, and I go to review and create. Once the function has been created, we can easily go to the newly created resource, and here it is. It's empty right now. You see that there are no actual functions inside this storage function, so I will go ahead and create a new one. You have different options for creating Azure function. You can use Visual Studio or Visual Studio Code as editors, or just any editor of your choice, like if you prefer Emacs for some reason. Or you can also go with in-portal experience. For very small, easy to program functions, in-portal experience would be the easiest one. So I will show you how it works. Inside the portal, you can you can start with specifying like how the function would fire. And here it can just fire periodically if you want to archive something, or if you want to generate reports once a day. That would be a good scenario for using timer functions. Or the function can be just the web API. Whenever you call a certain URL, it would get executed. And of course, there are also other templates, like if a message arrives into the queue or something else happens inside the cloud, you can use other triggers. In my case, I will use this webhook API, and I will create the function with webhook API. And here you have some sample function code inside the portal. So what this code does, it takes some URL parameter and just prints hello with this parameter. What we want to do, we want to use this function to store the URL which was provided to us by the bot. So in order to do that, we need to bind this function to some output storage. This is done through integration menu here. So you see that this function is triggered by HTTP request. It has no inputs, and the output is HTTP response. And what I want to do is I want to create the new output here. So the new output would be the Azure Blob Storage, but it can also be many other things. So Azure Blob Storage. And I specify here, first of all, the parameter which is used inside the function, which would be output blob. Or we can use function return value, but probably output blob is is the better idea, because I would use function output to say that everything is fine, to return back the OK status to the application. Uh, then I bind the storage account here, and because I don't have the my storage account here specified, I say new, and I select available storage accounts. It generates the record demo store 13 storage, which contains all the passwords and everything. And the output path would be out container and random GUID. So in my case, this is ideal because it would automatically generate the file name for me. I don't have to think about the file name. But if I want to specify the file name, I need to provide some other value here. So let me name the container output. So that is it. I need to save the storage, and I have my output parameter specified for the function. Note here that I can also create a new function which would be triggered by this output parameter. In this case, I can build the whole chain of Azure functions which fire one after the other, separating logic of my application into different microservices. So in my case, I have defined the output block parameter, but this parameter is not has not been yet included into the function. So I need to provide it here. And the type of parameter which I use here determines how I would provide this information inside the function. So for example, I need to provide blob as an output. So I can specify anything which can be stored into the blob. For example, I can specify an array here, or I can specify the stream. In my case, I would say stream, and I should name it output blob in the same way as I named it during the integration. So now let me remove the function body here and specify my own function body. It would be pretty simple. So first of all, I would take the URL parameter which is passed to me through the URL. So my bot would pass some URL to this function. Then I need to download this URL and store it into the blob storage. So to download, I use just normal HTTP client. I get the response, and then I specify response.content.copy to async. So I copy this to output blob. And I don't need to write any code to bind this to my output blob. I don't have to write all of that like imperative code, which I would do if it was just a normal web service. Azure Function Runtime does all of that for me. I just specify that I want to produce a result and put it somewhere, and this somewhere is specified declaratively during the integration phase. So that's it. I can now see how this function works. I can call it from, for example, from Postman. To do that, I get the function URL from here, and call it. What I also need to do, I need to provide the URL to retrieve. So I say HTTP URL equals HTTP, let's say google.com, and I send this request. And you see I received the result done here. This result was returned by our function. I can in fact trace the execution using the logs window here. It shows me whenever function call was made, and I can also log some intermediate results through this log object. Now let's make sure that the result was stored in the blob storage. To do that, let's go to the storage resource. So I will go to our demo bot storage and containers, And here is the output container which was produced by the function. And here are our files, and you can click and, for example, download them and make sure they have the right contents. Because the file has been downloaded without extension, that's why we need to specify with which application do we need to open it. So if I open it with Notepad, here we can see the contents of the page which we have retrieved. So now if we want to add this functionality to our bot, we need to make the call, the HTTP call to our function from inside the bot code. So here what I need to do is to create the HTTP client and do the asynchronous call to the URL of our function, passing it the URL of the image provided by the bot. So URL is the original URL of the attachment. In case of Telegram, for example, this URL would be somewhere on the Telegram server, and the Azure function would download this URL and store it in the blob. So to see this in action, I now need to republish the blob code to the cloud. So just do the deployment again, and then try interacting with the bot in Telegram. So I will send the image to the bot again, and hopefully it will give me the same result that it's Bucharest. Yeah, indeed it did. And now I refresh the blog, and I can see that the image is stored here, and I can in fact have a look at it. And again, I need to open this in the directory and open with, let's say, paint. And we see the image. Finally, if you are developing Internet of Things application, your job would be to ingest the messages which come from sensors into the cloud. And to do that, there are some specific technologies as well. The most important one being Azure IoT Hub. IoT Hub represents an endpoint which you can give to your sensor. It's an MQTT or AMQT endpoint where you can push a lot of frequent messages, and it will accumulate all of them and will give you an ability to process them in a timely manner. So that is the easiest way, and then you can process the messages inside IoT Hub either using Azure Function, which we have already described, or using some specific technologies like Azure Stream Analytics. But I will not go into detail here, and the link to documentation is provided here on the slide. So we have covered some different platform services inside Microsoft Azure that would allow you to construct your application from simple building blocks in an easy and fast way. But if you, for some reason, want to use more traditional microservice architecture, if you are familiar with Kubernetes, you can, of course, also use that. Inside Azure, Kubernetes is first-class citizen technology, so you can quite easily deploy your Kubernetes application in Azure using AKS, Azure Kubernetes Service. I find this to be more complicated than using platform services, so this technology is somewhere in between raw infrastructure and platform, but in case you are familiar with it, definitely feel free to use it as well. Also, what I want to mention is that I have covered just some of the Azure services, but I believe they are most important because they allow you to implement most frequent scenarios which arise during hackathons. But of course, there are also other services. There are services which allow you to build secure applications, that allow you to build authentication and mobile applications, do content delivery through different regions, and so on. Many different things which you can implement in Azure. But typically they are much less important if you want to build a fast working prototype from scratch. So now you know places where to look, and I believe if you get yourself familiar with those most important Azure technologies, you would be able to build applications and hackathons very fast, and this would be the best way to win a hackathon. So thank you for watching this. My name is Dmitry Soshnikov. I am cloud developer advocate at Microsoft, and one of my jobs is to collect feedback on Microsoft products. So if something doesn't work for you right during this hackathon, please feel free to send me feedback. Tell me if something doesn't work, tell me if something is very difficult to use, and I will pass this feedback on to my colleagues at Microsoft, and it will give us the opportunity to improve our products. Thanks again, and I wish you good luck during this hackathon. Bye bye.